Previously, if there was a new, fatal, communicable disease, the correct policy was to identify everyone who had got it and isolate them quick. Because that way, you stopped everyone else from getting it. That was the common sense policy. But no, the usual suspects came along, a new consensus was created and pushed in the press, and they said it would be discriminatory to distinguish between people who've got HIV and people who haven't. So they didn't identify them. They didn't isolate them when they could and should have done, when there were only a few thousand people worldwide who were infected. And instead they did nothing. Result, 33 million dead because of that consensus. 33 million infected and going to die, for there is still no cure for HIV yet available on the market. Though I'm pleased to say I am working on one which shows a little sign of doing some good towards it. So these are the consensuses that have gone wrong. And consensus has been, and really ought to be by now, in the light of these examples, a dirty word. Nevertheless, I'm going to make some concessions to the other side of the argument, because in medieval disputation, it was regarded as gracious if you made as many concessions to your opponents as you possibly could. And so I'm going to make some concessions now. Let's have a look at them. Here are some questions. Is there such a thing as a greenhouse effect? Does it cause warming? Does CO2 add to it? Are we adding CO2 to the atmosphere? Are we therefore causing some warming? I'm going to say, as the medieval Romans were, the medieval scholars would have said, concedo, I concede all of those points. And you may think, well, what's he doing here in that case, if he's agreeing with the other side? Well, what I'm agreeing on is those points which are settled science, not because there's a consensus, but because these points have been established by experiment and measurement and observation and the application of previously established scientific theory to the results. That is how science is done, not by consensus. And so let's have a look at how the IPCC, the Intergovernmental Panel on Climate Change, does its science. Because it does it in a very peculiar way by using computer models, and we're going to see whether this is likely to work or not. So let's have a look, first of all, at something that we can prove in science, something that you will have been made to try and learn how to prove at school, the theorem of Pythagoras. And here is one of the most elegant, simple proofs without words of the theorem of Pythagoras. It's by the Hindu mathematician Aryabhata from the 5th century AD. The square on the hypotenuse is, on the right there, indeed equal to the sum of the squares on the other two sides. And you can see that just by looking at that diagram. And that is a complete, satisfying mathematical proof of that truth. And once that is proven, that is settled science. And so we have many strands from which we get our learning, and we should always be willing to do them credit where they have made genuine contributions to it. And by pinching those two ideas, I developed my own proof of the theorem of Pythagoras. But now, climate isn't like that. In the climate, as in most of the physical sciences, absolute proof is almost never available to us. And we're going to see how we therefore approach scientific truth in the absence of absolute proof a bit later on. But here, Edward Lorenz, the father of trying to use computers to forecast the climate and the weather, wrote a paper in 1963 in the Journal of Climatological Sciences, one of the most famous papers ever written. This was the paper that founded an entire new branch of mathematics called chaos theory. And he says that in view of the inevitable inaccuracy and incompleteness of weather observations, precise, very long-range weather forecasting would seem to be non-existent. In other words, you can't use computers more than a few weeks ahead to tell what the climate is going to do. And we're going to see why that is. First of all, there are many objects which are mathematically chaotic. Even a pendulum can, in certain circumstances, behave in a way which ceases to be ordered and becomes chaotic. So can an attempt to forecast growth in population. If the rate of growth exceeds 3 in the Verhulst population model here, then you get this kind of knitting pattern that appears. And unless you know exactly what the value of the variable R, which expresses the rate of growth in population, is, you can't tell where you are and where the equation is going to go next. Let's have another look at it. Oh yes, now this one you'll like, because the cricket also is a chaotic object. And who, after all, would have thought that England would have regained the Ashes and then, second time round, would have held on to them? Just thought I'd rub it in. So, let's take a simple chaotic function. As you can see, it's not a very complicated equation. And what I'm going to do is to get it to draw a picture, because you can get functions and equations to draw pictures if you want. And we're going to start at the top left and come down to the bottom right of the screen. And the top left value of the parameter c, which is a complex number, I won't bore you with what that is in green there, and the bottom right value is in blue. And the interesting thing about those two values is that except for the last 3 or 4 digits of a 16-digit precision, they are just about identical. And yet, we're going to see what an interesting pattern emerges. You might think it would be something simple like this, but now, watch the screen and be amazed. That is the picture that this equation actually draws. I kid you not, I did not draw this with my paint box and crayons. No, I wrote my speech with those. This is what that function actually produces. And even though the starting and ending values, back one, starting and ending values of the equation are near identical, you still get these fundamental changes. Now, well, how is this relevant to the climate? Well, what it means is that the climate is an object where you get these little changes going on all the time for natural reasons. And even a really tiny change can have a huge effect, such as the Brisbane flood, which happened last December. And of course the usual suspects immediately began to say, this is because of global warming. Everybody knows that. There's a consensus. And in fact, they're not right, because this flood occurred in 1893. Long before we could have had any influence. This raises the question, I wonder whether the number of floods on the Brisbane River has been increasing as a result of global warming, because that's what we're told by the consensus. Right, let's have a look. Between 1840 and 1900, the number of floods, the blue lines going up above the red horizontal line, those are the serious floods as defined by your Bureau of Meteorology. There were 8 of them in just 60 years. In the next 110 years, a period nearly twice as long, there were only 3 serious floods, of which the December flood of last year was one. Hardly, as you may think, the profile of a deteriorating situation caused by global warming. And once we see the actual facts and the actual data, then all these scare stories that you see over and over again in the newspapers and on the lips of your colleagues fade away, because we have the perspective of the truth. And there is a moral dimension to this, which I shall be referring to all the way through this talk, that we are losing the truth in Australia and in the West because so many lies are being told about the climate, and I am here to put that right.